Mean value theorem.
Yes.
Does it?
Well, doesn't it have to be differentiable in the open interval, so it doesn't have to be differentiable at 0, just right next to it?
Oh, yes.
So this one actually is good.
I think so.
Is this continuous on the closed interval? Is it continuous?
Yeah.
Continuous.
Yes.
Continuous?
Yeah.
Yeah, continuous. Differentiable on the open interval now. Now, at 0, what happens? What's that called? It's a cusp, which means
It's not
differentiable at that point.
it's not differentiable at that point. But you want differentiable on the open interval. Because really what's happening here is this. You know what I'm saying? Even though at one point it's got that vertical, but you're not really like inclining like everything to the right of it. So it is. It's differentiable on the open interval. This one's actually good. Okay? So it should satisfy it. So what does mean value theorem say, and what are we doing? What's our goal with mean value theorem? MVT. What does it state? Sandy. You heard me. Sandy. What?
What?
Thank goodness for notes.
Yeah.
Let's flip back those 2 pages. And mean value theorem tells us what, Eleanor?
That it's differentiable on the open interval and continuous on the closed interval, that there is some point C at which the instantaneous rate of change and the average rate of change are the same.
Perfect. Okay. So what do I need to do first in order to even prove this thing and to find that one point? What's the first thing I should do? Yeah, find the 2 points and do what with it? Yeah, find the average rate of change. Find the slope of the secant line. Find the average rate of change on the interval. I plug a 0 into here, and what do I get?
0.
I plug a 1 into here, and what do I get? Okay? So I do y2 minus y1 over x2 minus x1, and I get an average rate of change equal to what? The mean value theorem says there exists one point C such that the average rate of change equals the instantaneous at this point C. So what can I do now to figure out where that point is? Take the derivative of the function of x to the 2/3. What's the derivative of x to the 2/3? Y prime equals 2/3 x to the 2/3 minus 3/3 is? Yes, x to the negative 1/3. I don't like the way this is written. What do I do with negative exponents? Flip it. This is on top. This is on bottom. So this is the same as 2 over 3x to the 1/3. And you guys see why the derivative doesn't exist at 0? Do you see it? Because you'd have a 0 in the denominator. So it matches up. This cusp for this function is matching with the derivative. Derivative is fine everywhere except for 0. And same here. Okay? It works. Okay? So now I have my derivative equation. This derivative equation will give me the instantaneous rate of change for any x value that I choose. And I also have the average rate of change on the interval. And what do I want to do here? Set them equal. So let's have some fun algebra here. 2 over x, 3x to the 1/3 equals 1. Let's do it, Estella. Take me through it.
Okay, so you multiply by 3x to the 1/3.
Okay, both sides, and you get what?
So equals 3x to the 1/3.
Okay, then what do you do?
Divide by 3.
Great. Then what do you do?
Take the cube root of 2.
The cube root? This is the tricky part. What do we do now? In order to get x by itself, if you cube rooted both sides, you would have x to the 1/3 raised to the 1/3 exponent. Exponents raised to exponents, what do? Multiply. Exponents raised to exponents, you multiply it. Sonia, what should we do? y cube it. both sides.
1/3 times 3 equals 1.
Yeah. See the difference, you guys? Again, exponents, raised to exponents, you multiply. 1/3 times 3 is 1. So this is x equals 2/3 cubed. Or just cube everything in there, and what do I get?
8 over 21.
Yeah. Is this a number between 0 and 1?
Yes.
Yeah. So there it is. There it is. Again, if you wanted to check it, you can plug it back in, or check your table on your graph to make sure, add, or trace to 8 over 27 to make sure that you got a slope there of 1 on the derivative. Okay? Was that fun or no? Did we like that? If you thought that was fun, then wait till you get to number 20. Talk about it in your groups. Give it a shot. The numbers are more fun if you change it from 1 to 5 instead of 1 to 3. Change 20 to this. Not even that, but yeah, the whole equation of the secant line. With this function on this interval, the equation of the secant line and yes, the equation of the tangent line. How do you go about these goals? Again, make sure everyone changes their interval from 1 to 5. Problem's more funny.